Hey there, warriors. Here we go with a little bit of trig. All right, we're going to start with this circle today, and this should look familiar. Hopefully you guys watched that video I posted yesterday. I'm going to fill this in. I want you guys to be thinking about the conversion of degrees to radians as we draw. So remember that every angle that we draw first starts on our positive x-axis. Okay, we call that the initial ray of our angle. And as we measure an angle, a positive angle is always going to go counterclockwise to the left, okay, or up. A negative angle is going to go down, okay, positive up, negative down, okay. Now, as we're thinking about radians, you guys can really think about this as I go all the way to here. And the reason I'm only showing half this, because I want you to think about this as one whole, right? One whole pi, 1 over 1, and that's 180 degrees. And what we're going to do is we're going to divide this thing up into pieces. So we divide it into 2, and we put this right here. That is going to be 1/2 pi, or pi over 2. Okay. As we continue to divide this, we can divide this into fourths, and that would be 1/4 pi. 2/4 pi is 1/2, and 3/4 pi. Okay. We can then divide this into. We can also divide this into sixths. 1/6 pi. And as we go here to our 2/6, 2/6 is going to simplify to 1/3 pi. So 1/6, 2/6, 3/6 is half. 4/6 simplifies to 2/3, and then 5/6 is right here. So remember, as we do radians, these are all just fractions or pieces of pi, which is half of this circle. All right, now if it helps to put the radians or the degrees with the radians, then do that. Remember that pi is 180 degrees, so 1/6 of 180 is 180 divided by 6, 30 degrees. Okay, and I'm going to go, each time I add a sixth, I'm adding 30 degrees. So that's 30 degrees, that's 60 degrees, that's 90 degrees. I'm going to label that in red in a second. 90 plus, that's 120, and that's 150. Okay. As we do our 1/4, 180 divided by 4 is 45 degrees, plus 45 gives me 90, plus 45 again gives me 135 degrees. So make sure you're comfortable with these, because these are the measures that we are going to be finding without a calculator. So the first thing you guys have to know is, where are they on the coordinate plane? And that's very important as we begin finding these trig functions. Now, as we continue to move through our circle, remember that this is a whole pi on the bottom too. So we're just adding to what's already there. So if I add another 1/2 pi to that, I'm going to add 1 pi plus 1/2 is 1.5 pi, or 3/2 pi. And add another 1/2, and we get 2 pi. Okay. If you want to put the degrees in there right away, add 90 degrees, 270, and 360 degrees. Okay. Now let's go ahead and divide it again. So let's do our 45s, or pi over 4. Add a fourth, 4 pi over 4, 5 pi over 4. Add 45 degrees, and that's 225. Add a fourth, we get to 6 pi over 4, which simplifies here. Add 45 degrees. Add 45 degrees again. Add a fourth again. So that's 6 pi over 4. That's 7 pi over 4. And 270 plus 45 is 315 degrees. So you guys can find all of these by just thinking about these increments that we're adding. The next thing I like to do is the 60s, or the 30s. So 180 plus 30 is 210. Remember that this is a sixth. So 6 pi over 6, 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. Add another 30, and that's 240. Add another 30, that's 270. 8 pi over 6, 9 pi over 6, 10 pi over 6 is 5 pi over 3. Add another 30, that's 300. 10 pi over 6, 11 pi over 6, and add another 30, and that's 330 degrees. Okay, you guys should be able to work your way around the circle and fill in all of these pieces. Again, it's very important that you can find all of these angles on the coordinate plane and know where they are. All right, so now let's talk about how we're going to be using these things. So this, again, should look familiar. We started this right as we left off. Okay, now, as we look at just this first quadrant, when we look at each of these angles, okay, each of these makes a right angle if we take the hypotenuse, draw it out to where it hits that circle, and drop an altitude down. It makes a right triangle. Okay, now, for our purpose, what we're going to use is a radius of 2. So for each of these, the hypotenuse is going to be 2. And I'll show you guys why in a second, because all of these are going to be our special right triangles. Now, a lot of people make this a unit circle and have the hypotenuse equal to 1. I like it to be 2 because these are the ratios that you guys used in geometry. So when we do a 30, 60, 90, that hypotenuse is 2. The side opposite 30's half of that is 1. The side opposite 60 is root 3. Okay, that should look familiar. If it's not, you need to write it, you need to practice, make sure you know it. Because once you fill that in, now we can fill in all of these trig functions. So sine 30 is opposite over hypotenuse, is 1/2. Cosine 30 is adjacent over hypotenuse, is root 3 over 2. And tangent 30 is opposite over adjacent, is 1 over root 3. And remember, what we're going to do here is that we're going to switch those to get them out of the denominator. We multiply by that radical, and we get root 3 over 3. These are going to be really, really important, especially for you guys that are taking pre-calc next year. All right, check it out. The next one we'll do is this 45. So when we draw that triangle, we drop that altitude down. We make our 45, 45, 90 triangle. Now again, we're going to use that radius as 2, so the hypotenuse is 2 again, and this should look familiar from your special right triangles. Hypotenuse 2, legs are root 2 and root 2. And again, now we can do our sine, cosine, and tan. So opposite is root 2 over hypotenuse is 2. Cosine opposite is root 2 over hypotenuse is 2. And tan opposite is root 2 over adjacent is root 2. And simplify that now, and it's just equal to 1. Okay? You guys get the idea? Okay. Next one, draw our 60 degree, drop that altitude. Hypotenuse is 2. There's our 30, 60, 90 triangle again. You want it oriented the same way, we can do it like this, but it's the same as that triangle we had up there. So remember, our hypotenuse is here, side opposite 30 is 1, side opposite 60 is root 3. Now look at the pattern here. Sine 60, now opposite over hypotenuse, is root 3 over 2. Notice that was the same as cosine 30. So see how those switched because the angles switched in the triangle. Same sides, different opposite sides for each one. Cosine is adjacent over hypotenuse, 1/2, and tangent is going to be opposite over adjacent. And there we go. Now, if you can remember these 3 triangles, you can find any of the angles that, or any of the trig functions we're going to find for any of the angles in the coordinate plane for our exact values. They're all going to be combinations of these, okay? Pause that, watch it again if you need to. Make sure that you guys copy these down and have that quick reference if you don't have them memorized. Okay, this is very important that you know these. And not just important for our test next week, but very important for pre-calc next year. All right, so let's see what these are going to look like. This is it. This is what the problems look like. Now, you could just put these in your calculator, but you may not use a calculator here. If you do, you're not going to be helping yourself because I need exact answers. Okay, I don't want decimals. All right. I also am going to want to see your work, so I'm going to want to see you drawing these things, setting up your triangles. If you guys give me just an answer, I'm not going to give you any credit. All right. This is the way you're going to see it in pre-calc next year. All right. So what we're going to do is first we're going to draw this angle, and that's why I said it's important that you guys know where that coordinate plane is and know where an angle is. So if we draw that coordinate plane, I'm going to actually zoom in here so I can get a bigger box. Yeah, that's better. Okay, so let's draw a coordinate plane, and let's go ahead and draw this angle. Now, this one's in that first quadrant, so it's exactly like what we just did, all right? So draw a coordinate plane, and notice I want it in that first quadrant. Okay, I'm going to go ahead and draw that 60-degree angle, drop my altitude down, and label this. That's where my angle is in this quadrant. Okay, so hypotenuse is 2, opposite 30 is 1, opposite 60 is root 3. All right, once you guys draw that triangle in that quadrant, that's all you have to do now. Say, okay, sine of 60, opposite over hypotenuse. And that's our answer. Again, if you put this in your calculator, you're going to get a decimal that goes on forever. That's not what I want. This is the answer that I want. And I want to see that drawn. I want to see that work to go with it. Okay? All right, let's keep going. Let's do another one. Now, 7 pi over 6, we're in radians. So you're going to have to work a little bit here and think about where this is. Or you can convert it to degrees if you really want to. Okay? 7 pi over 6, remember, this is 1. 6 pi over 6 is right here. So 7 pi over 6 is just past that. And its denominator is pi over 6. So that's 7 pi over 6, which is 210, or that's 30 degrees. So when you guys draw this triangle, we're going to drop that altitude except put it up. And that's our reference angle. Okay? So this is 7 pi over 6. That reference angle is pi over 6, or 30 degrees. Okay, again, I switched to degrees here because I want you guys getting used to just thinking about this as these special triangles. So opposite 30 is 1, right? Hypotenuse is 2. Opposite 60 is not root 6, is root 3. And now as we do that, here's what's important now. And this is what changes when we're in these different quadrants. Think about this as a coordinate plane. Instead of going to the right and going up where this quadrant is positive, I went to the left, and I went to the left negative root 3. So that's really a negative value there. Think about this as a coordinate plane as coordinates. And then I went down. Okay, so that means that that is also going to be negative. Now, my hypotenuse is always positive because that is irrelevant of what quadrant we're in, because the hypotenuse is always 2. Okay, so we're going to keep doing a few more of these so you guys can get the hang of it. We're going to do more to practice tomorrow, but think about this on the coordinate plane when we draw that now. So that means that sine of 7 pi over 6 is going to be the same as that. You're going to use that reference angle, but we're going to go opposite is negative 1 over hypotenuse, which is 2. So there's our solution for that one. All right, let's keep going. The more you guys see and the more you practice, the more sense it'll make. But you got to be comfortable with where these angles are going to go before we can start getting these. All right, 5 pi over 3. So 3 pi over 3 would go here, right? That means 4 pi over 3 is going to go here. 5 pi over 3 is going to go right here. Now, pi over 3 is, when you see that denominator, that reference angle is going to be a 60-degree one because it's pi over 3 is our reference angle, or 60 degrees. So again, there is our special right triangle on that coordinate plane. Now label it like we are on the coordinate plane. So this is our hypotenuse is 2. Side opposite 30 is 1. Now this goes right, so that's a positive 1. But this goes down, so that's a negative root 3. Okay, and as we do this now, all we got to do is look at that triangle, that reference angle in the triangle. So cosine pi over 3. Okay, here's our angle, but we're again looking at the reference angle, 60. Cosine is adjacent, okay, which is 1 over hypotenuse, which is 2. And there's our solution. Okay. I'll keep going. I'm going to do a few more for you guys. You can see that there are a bunch here. So I'm going to do a couple more. I'll do this one on top. Okay, switching back to degrees. Maybe you guys are more comfortable here, but it's the exact same thing. So if you want to, you can switch to radians to degrees right at the beginning. I can do one like that for you guys too, if that helps. All right, 315 I know is going to be boom all the way around here into that fourth quadrant again. 360 minus 315, our reference angle, remember, goes up here. There's our reference angle is 45. This is why those reference angles are so important. So here's my 45, 45, 90. And label our triangle. Positive, okay, so our hypotenuse is 2. Legs are root 2, so that goes to the right, so it's positive, but this leg goes down, so it's negative root 2. Okay, those signs are going to be really important. Okay, now we want cosine of that angle. So cosine of 315 equals adjacent, which is positive root 2, over hypotenuse, which is positive root 2 again, or positive 2. All right, so they're all like this, guys. You got to be comfortable with those special right triangles. Think about where each side is going to be negative, and then comfortable with your radians and drawing those angles. I'm going to do another radian one. Let's go ahead and do a conversion. I guess let's do a negative one first, because you guys might be thinking, what do I do with that negative? And it's not going to be any different than what we just did. Remember, on the coordinate plane, we're going to start when negative goes down instead of up. Pi over 3 is going to put us right here. If you guys do that conversion, that's 60 degrees. So here's our triangle. Hypotenuse is 2. Side opposite 30 is 1. Side opposite 60 is root 3. But since that goes down, it's going to be negative root 3 again. Okay, so notice that's exactly the same as what we just did. Okay, same angle, a different triangle. Okay, so let's go, or sorry, different triangle. So let's go here. Cosine negative pi over 3 equals adjacent, which is positive 1, over hypotenuse, which is 1, which is 2. Okay. All right, let's do a secant. So secant. Okay, let's do a couple things here to make this easier for ourselves. Some of you guys might be saying, I don't like the radians. Let's convert it to degrees. Okay, so here we go. Real quick reminder how to convert to degrees. Remember that pi equals 180. I want to get rid of pi because I'm converting to degrees. So pi goes on the bottom, 180 goes on top. Okay, so really all we have to do to convert to degrees, these pi's cancel. You multiply 11 times 180. You can do this quickly in your calculator. Okay, 11 times 180, and then we divide by 6. And that's going to simplify it for us and everything. So if you'd rather work in degrees, there you go. That's the same as 330 degrees. Now, secants, we have to think about this. This is one of our co-functions, right? Our reciprocal functions. Secant goes with cosine. So cosine equals adjacent over hypotenuse, which means secant equals that reciprocal, hypotenuse over adjacent. Okay, that's going to write out all your thoughts. Think about that. All right, now let's go ahead and draw our angle, and we'll get our answer up here. All right, so I know 330 is going to be right here, all the way around. That means my reference angle is going to be 30 when I draw this triangle up. There's my 30, 60, 90. Hypotenuse is 2. Side opposite 30 is 1. But this is going down, so it's going to be negative 1. This is going to the right. It's going to be positive 3. Okay, so now I'm going to do secant right here, which is going to be, I can squeeze it in over here. Secant 11 pi over 6 equals hypotenuse over adjacent, and that's going to be 2 over root 3 is my adjacent. And we got to do a little bit more work because we got to get that radical out of the denominator, times root 3 times root 3. All right, so our final answer, I'm sorry I didn't leave myself enough room to make this look nice for you guys. Final answer is going to be 2 root 3 over 3. All right. I want you guys to try these out. I'll do one more for you guys. Let's do this guy. Tangent. We haven't done the tangent yet. And it's 3 pi over 4. So remember, this is 4 pi over 4. It helps you get your bearings. 3 pi over 4 is less than that. It's going to be right here. Okay. There's 3 pi over 4, which means my reference angle is pi over 4, which is 45 degrees. Draw your special right triangle. Hypotenuse is 2. Legs are root 2 and root 2. Now again, think about this on the coordinate plane. Because we're going to the left in that second quadrant, that makes this your x-coordinate negative root 2. And up, this one stays positive. So now tangent of 3 pi over 4 equals tangent is opposite over adjacent, which is going to be root 2 over negative root 2, which is negative 1. Okay. All right. I'm going to leave you guys with the rest for practice. Email me. I'll post these solutions on the drive for you guys. Email me if you have questions. Tomorrow, we're going to do the quadrantal angles. So as you guys are doing the homework or starting the homework, if you get things like 180 and 90, 270, 360, okay, we're going to take care of those tomorrow. So just skip those and come back to them. All right. Keep up the good work. I'm missing seeing you guys. Send me messages, send me emails, whatever you need if you have questions. I'm really happy with the work a lot of you guys are doing, so please keep that up. And this is really important stuff for pre-calc next year, so I want to make sure you guys are feeling good about it as we get into this trig unit more. All right, I'll talk to you later.